screen pointer. Okay students, in the previous slides, in the last lecture, lecture number 10, we have discussed the synchronous counter, 3-bit counter. Today, in today's lecture, we will discuss the synchronous up-down counter. As its name indicates, up-down. Up-down means it will count up, it will count down, means it will count from 0 to 7 and then it will count from 7 to 0. You understand this? That means 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, and then after 7 it will again to go to 0. Like I have written here, 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, and then again to 0. Okay, down counter means it will count from 7 to 6, 6 to 5, 5 to 4, 4 to 3, 3 to 1, 3 to 2, 2 to 1, 1 to 0, and then again it will count to 7. Okay, so that means there is a design, there will be one counter and it will perform two functions, up and down. Okay, so I have written here for explanation, an up-down counter is one that is capable of progressing in ascending or descending order through a certain sequence. An up-down counter is also called a bidirectional counter. Bidirectional, why bidirectional? Because it is going to count in both the directions, up and the down. Here it is very important, this part. Up-down operation of a counter is controlled by up-down signal. It is down bar. Okay, when this signal is high, okay, high means 1, counter goes up sequence, that means 0, 1, 2, 3 till n. When up down signal is low, that means when it is 0, counter follows down sequence. Okay, so up and down, this is up 0 to 7 and this is down 7 to 0. It is for 3-bit. If it is for 4-bit, then it will be 0 to 15. If it for 2 bits, then it will be 0 to 3. Okay, so you can get any bit up down counter. Okay, so this is synchronous. Slide here. Okay, so because I am using T flip-flop to design it, you can use any flip-flop like JK, SR and D flip-flop. Okay, so for convenience I am using T flip-flop because in T flip-flop there will be only one table. You all know the excitation table of flip-flop, right? It is 0, 1, 1, 0. This is my present state, this is the next state. So here it is just the same as we have done the synchronous 3-bit counter, present state, next state and the flip-flop inputs. In 3-bit counter I have used JK flip-flop, here I am using T flip-flop. So same we will do. Now the thing is, it is up-down counter. So I have denoted up-down counter with QD. Okay, you can use any symbol like UD, U, anything you want to use. I have used QD. Okay, so it is QD, Q2, Q1, Q0. It is the present state and this is my next state. Okay, now because it is counting up and down, and I have told you that if it is 1, that means it will count up sequence, and if it is 0, it will count the down sequence. Okay, so 8 places I will write 0 and then 8 will be a 1. Okay, so 8 times it will be 0, it will be 1. Now present state and the next state. Now this is very important, how to fulfill this next state. You can see 0, 0, 0. Now this is 0, that means what it is going to count? It is counting the down sequence. So I cannot go back to the previous slide, but you can go back to the previous slide and you can see I have marked the arrow with the down sequence. So after 0, 0, 0, it will count 1, 1, 1. After 0, 0, 1, it will count 0, 0, 0. After 0, 1, 0, it will count 0, 0, 1. Just mark the down sequence here. Okay, and this is the up sequence. 0, 0, 0, so next state will be 0, 0, 1. 0, 0, 1, next state will be 0, 1, 0. Okay, so and after 1, 1, 1, it will again count to 0, 0, 0. So it is the same operation as the normal counter, and it is the descending order. This is the ascending order. Okay, You all know now how to fill this flip-flop inputs is T2, T1 and T0 as we did in the JK flip-flop. This is my excitation table here. This is my excitation table. So for 0 and 0, the output is 0. So we will see here 0 and 1. What is 0 and 1? The output is 1. So I will write 1 here. For T1, we will use 0 and 1. So for 0 and 1, again it is 1. Okay, for T0, we will use Q0 and this Q0 bar. So this will be 1. So you can fill this excitation table. You all know how to fill this excitation table. Okay. Now there will be how many K-maps? It will be 1, 2 and 3. 3 K-maps will be there, T2, T1 and T0. If we would have used the JK flip-flop, then there will be 6 flip-flops, 6 K-maps. Okay. So now there is no don't care condition here. So we will just write the ones in the K-map. There is no need to write zeros, only the ones. Okay. So this is the K-map for T2. Now how we will decide we will use the 2 variable K-map or 3 variable K-map or 4 variable K-map, because this is 16 combinations. So we are going to use the 4 variable K-map. So this is my 4 variable K-map. I have taken here QD, QD, Q2, Q1 and Q0. Q2, Q1 and Q0. This is my combination. I will fill like this. I have written here 0 to 15 number here. 0, it is 1 here. So at place of 0, I will write 1. Then 4 here, I will write 1. I have written 1 here. And then it is 15th. Number 15, it is 1. I have written 1 here. And number 11, it is 1. So I have written 1 here. And I have paired it, this pair and this pair. We all know how to write the equation for the K-map. We have done in Digital Systems 1. If we see the left hand side, it is 0, 0 and 0, 1. That means what is the thing which is common? It is 0. Okay. So 0 is common. That means I will write QD bar. So this is my QD bar. And on the top, it is Q1 and Q0 and it is 0 and 0. So it will be Q1 bar and Q0 bar. Same with this pair. We'll see at the left 1 is common. At the left 1 is common, so we will write QD, and on the top it is 1 and 1, so we will write Q1 and Q0. So this is my equation for T0. Same we will do with T1 and same we will do with T0. Okay, let's go to the next slide. Here you can see I have made the K-map for T1. You can see here, and you can use the excitation table from the previous slide, and then you can fill the K-map and write the equation for T1. And same you can do for T0 as well. For T0, if you will see the excitation table, all are 1s. So I have written all 1s and pair it all together. So T0 will be 1. Okay. So I have written here the equation for T0, T1 and T0. Now this is the design of up-down counter. Obviously it is not very neat and clean, please, because I was not having the much space here, but please make it neat. When you are doing your work, make it neat. So you can see, as we have done for the JK flip-flop, I have done for T0 this T flip-flop, T0, T1 and T2. Clock pulse, first connect the clock pulse together. I have connected all the clock pulse together here, and you can see what is T0. T0 is 1. I have given it here 1. What is T1? T1 was the multiplication of QD, Q1 and Q0, okay, plus multiplication of all the bars. So I have written here, it's not very neat and clean, but if you will try to understand, you will understand this. It is QD and this is QD bar. Okay, this is QD, this is QD bar, and this is QD, the first AND gate. This is Q0, the another input. And what was the next input? The next input was QD, Q0, and what was the next input? I can't go back. I think it was Q1. So take Q1. Okay, so these are the inputs here. These are the inputs for the next AND gate, and connect it with the NOT gate and connect it to the T1. Okay, sorry, T1 is QD and Q0. So these are only the two inputs, QD and Q0, and these are the two inputs, QD bar and Q0 bar. So these are the two inputs, QD bar and Q0 bar. From here, Q0 bar. So connected with the NOT gate, OR gate, and then connected to the T1. Next is T0, T2. T2, as we have done on the previous slide, I can't go back there. So T2 was the combination of QD, Q1 and Q0. I have connected all these three with the AND gates, and the multiplication of QD bar, Q1 bar and Q0 bar I have connected with the AND gate, and then connected with the NOT gate and connected to the T2, and this is my output. So this is the connection of my up-down counter. I think it is clear. If you have any queries, then you can just let me know. I will solve your queries, but listen this video twice or thrice so that you can understand what I have spoken in this video. Now come to the assignment. This is assignment number 5. So this is the work for the next week. Okay, so this is the 17th, next Wednesday till 24th June. Okay, so the lecture number 10th was for the this week, and lecture number 11 was for the next week. Now this one is determine the count sequence for the given logic circuit. It's tricky. I know if all the concepts of counters are clear, then obviously you will be able to do it. Okay, so this is the two flip-flops J and JB. I have made the schematic. Okay, I have not done the truth table and everything. I have just made the schematic, the final circuit diagram. You have to determine the count sequence for the given logic circuit. That means you have to determine what is the sequence it is counting. Okay, so first you will see what is the equation for JA, KA, JB and KB. From the equation you will go to the truth table. Okay, try to do this. If all the concepts of counters are clear, you can easily do this question. Okay, use your like, apply all the concepts. You will be able to do it. I know that. Next is draw the state diagram of a modulo 4 up-down counter. Design its circuit using JK flip-flop. Now it is modulo 4. So it will count 4 states. Okay, you have to design using the JK flip-flop. Okay, next is your synchronous. Design a synchronous gray code mod 6 up counter using JK flip-flop. So you have to design a gray code mod 6. Mod 6 means it will count 6 states. Okay, I have given, for example, how to write the gray code. Suppose the number is given to you 1010, so you will write the number, the first number as it is, and then you will add these two numbers. 1 plus 0 is 1. You will write 1. Then you will add these two numbers, you will write 1. Then you will add these two numbers, you will write 1. So gray code for this number is 1111. Okay, so you have to do the gray code for mod 6 up counter. Okay, so you will write the 6 states. Then in the next state you will write the gray code of the number, and then you will design the counter using JK flip-flop. Try to do it. Next, question number 4 is a design a counter to count sequence 4 6 7 3 1. So this is the sequence which is random. So when you will do the state diagram, you will write 4 6 7 3 1, then again 4. Okay, using JK flip-flops. Unused states must be taken don't care. If there are unused states, you just write don't care. Here also, if there is unused state, you will write don't care. Okay, I think these are the 4 questions you will do for the next week. If there is any queries, you can just email me or you can just WhatsApp me. I'll solve your queries. Thank you. That's all for today.